Good morning, everyone. I am excited to be here this morning to tell you about the latest set of capabilities that IBM is bringing to our users in collaboration with our ecosystem partners. So it's a quantum software ecosystem story. So I would like to start by talking about our mission statement. Our mission at IBM is to bring useful quantum computing to the world and to make the world quantum safe. Today, I'm going to focus on the first part of bringing useful quantum computing to the world. So what does it take to deliver useful quantum computing to the world? The first is better processors, so speed, quality, and scale. And over the last 8 or so years, we have set an ambitious roadmap where we've publicly disclosed our goals, and we have consistently and successfully checked off those goals, and we're continuing to do so today. The second piece is a performant quantum infrastructure software. I hope most of you are familiar with Qiskit, our open source SDK, that studies have shown is not only the most performant, but also the most preferred quantum SDK. If we want to enable increasingly complex workloads, then the software has to be performant at all levels of the stack, from the QPU all the way up to the user. Now, the final piece is algorithm discovery. And what goes in here are the tools and capabilities that allow users to take the hardware, the software, and do useful quantum computing with it. And that's where the capabilities that we're bringing to our users fit in. So up here on the screen, you see our Heron processor. This is our most performant quantum processor and also the foundation for scaling of our future systems. Earlier this year, we announced Flamingo and Crossbill, which demonstrate progress that we've made on our coupler technology. Both Flamingo and Crossbill take several Heron processors and link them together using couplers, showing our path for scaling in a modular way to much larger systems in the future. Here in this picture, you see how quantum needs to fit in as part of a larger heterogeneous workflow that includes several different types of compute resources. Sitting on top of the classical and quantum compute environment is the Qiskit ecosystem that's in the big purple box. But there's actually a lot more structure within that purple box. In fact, there's an entire software stack within that purple box. You see the heterogeneous orchestration layer. Above that, we have the development tools that allow users to build and run algorithms. And then we have the abstraction services that extend into the applications and functions that enable users. The software stack has to be performant at every layer, but it also has to be intuitive and easy to use. So speaking of easy to use, Qiskit is available on 10 different backends, so it's not just for IBM quantum hardware. And in a recent study by the Unitary Fund in 2024, nearly 75% of quantum programmers said they prefer Qiskit as their quantum SDK over any other quantum SDK. And Qiskit has built a strong ecosystem around it, with nearly 3/4 of its contributors being external to IBM. And Qiskit has been integrated into much of the quantum landscape, with nearly 5,200 projects today that are dependent on Qiskit. So we have to make sure that Qiskit is, in fact, the best SDK out there. And we can't say that Qiskit is the highest performing SDK unless we benchmark it against other quantum SDKs. So that's what we did. This year, we created BenchPress, which is a transparent open source benchmarking tool that's based on industry standard tests. BenchPress tests the ability of a quantum SDK to perform important tasks such as generating and transpiling circuits, and it does so both in terms of speed as well as size of output circuit. It is made up of 1,000 or so tests, mostly from third-party libraries. So we use benchpress to benchmark several different quantum SDKs, including Qiskit, to see which one comes out on top. And the results, I'm happy to share that the current version of Qiskit is 58 times faster at transpiling circuits compared to the second best competitor, which was Qiskit. And it did so with 21% fewer 2-qubit gates. What that means is Qiskit creates more efficient circuits faster. And not only is Qiskit faster and more effective at creating more efficient circuits, but it also has the widest range of functionality. Qiskit passed the most out of the 1,000+ tests in benchpress, the most out of any other quantum SDK. So based on these results, we believe that Qiskit is the tool for doing utility scale work on quantum computers. So I've talked to you a little bit about the hardware and the software. Now, the third piece are the tools and capabilities that will enable users to solve big problems. But solving these big problems requires a dedicated community of industries, researchers, and users who are committed to algorithm discovery. So ecosystem is very important for this piece. Over the last few years, we have been building the largest network of partners, users, collaborators across geographies and industries. We have more than 250 members in our IBM Quantum Network. We have 41 quantum innovation centers with more than 125 members. We have more than 50 industry clients, more than 45 quantum startups, and more than 10 ecosystem partners. We also have a really large user base. We have more than 600,000 users of IBM Quantum who have collectively ran over 3 trillion circuits on the 75 systems that we've deployed since 2016. And today, our users are continuing to run circuits on the 8 online systems that we have, as well as the 5 client-located systems. And these quantum classical workflows are routed through our 2 global quantum data centers. We also prioritize investing resources in quantum education and building a diverse global quantum workforce. There are more than 700 courses that are taught using IBM Quantum tools and resources, and more than 22,000 students globally have attended in-person events at various campuses worldwide. We also have educational content that we make available through our YouTube channel and our learning platform, and those have both been quite popular, amassing more than 9 million views across all platforms. But it's not just IBM doing this. Our ecosystem partners are also collaborating with each other. One such example is our technical quantum working groups, where members of our network come together and define domain-specific use cases, challenges, and paths forward for optimization, material science and high-performance computing, high-energy physics, healthcare, life sciences, and the newest one, sustainability. These working groups have already published key white papers detailing the path towards quantum advantage in their respective areas. And we want this progress to continue. That's why we have programs that are designed to enable our ecosystem partners to innovate. One such example is our service and build program, where we work closely with systems integrators, consulting firms, software vendors, and startups to bring new quantum computing tools to users or to bring quantum to existing classical workflows. And now, We are proud to collaborate with our ecosystem, quantum startups in our network, as we bring our latest set of capabilities to users. These 5 startups that you see on the page, Algorithmic, Multiverse, Q-Control, Kedma, and Qnisys, they've been part of our network for a while, benefiting from our ecosystem program, and now they are central to the launch of Qiskit functions. Now, we collaborate with our ecosystem because we want to enable the broader community to do meaningful scientific work. And to do that, quantum must be performant, and I've talked a little bit about that, but the other piece is quantum has to be easy to use. So what does that mean? What it means is that we have to equip our users with the tools that they need to do useful work. Now, these tools are different based on who the user is and what the needs are. So here, this is how we think about our users. All the way on the left, you see what we call our quantum physicists. These are early adopters of quantum, have intimate knowledge of both the hardware and the software. And these are the users that are building capabilities on quantum computers for utility. These users are operating at the circuit level, and Qiskit is the right tool to enable these users to build capabilities for utility. In the middle column, you see what we call our quantum computational scientists. These are the users that are also familiar with quantum, and these are users that are focused on stacking capabilities to design algorithms. And they're designing algorithms for quantum advantage. For these sets of users, tools such as Qiskit add-ons, which I'll tell you about in just a minute, would be the right tools to enable these sets of users. Now, all the way on the right, we have the third set of users that we're currently unlocking. We call them broadly scientists. And these are users who have an understanding of quantum, its potential, its limitations, and also have deep domain expertise. These are users that are interested in using quantum algorithms to design applications for business value. And we believe Qiskit functions are the right tool to enable this set of users to deliver business value. So what is a Qiskit function? I'd like to start by first talking about the Qiskit pattern. This is the framework for how you build and run an algorithm. Qiskit pattern has 4 steps. The first step is the mapping step. Then you have optimize, execute, and post-process. Within each step, we have modular tools that perform specific tasks. And this is what we call add-ons. So for example, within the mapping step, we have multi-product formulas. Within optimize, there's circuit cutting, observable backpropagation. For the execute piece, there's Qiskit runtime primitives, and then for post-processing, there's sample-based quantum diagonalization and others. Now, if you stack these different tools together and package them up, then you get Qiskit functions. Qiskit functions are pre-packaged workflows that are designed to accelerate algorithm discovery and application prototyping. And we have 2 types of functions available, application functions and circuit functions. Application functions take all 4 steps of the Qiskit pattern and package it up into one workflow. And the inputs here are domain specific, so training data, molecule or graph data, and the outputs are also domain specific with a classifier, energies, or cost history, depending on the specific application. Today, we have 3 application functions available on our platform. We have Singularity Machine Learning by Multiverse, Optimization Solver by Q-Control, and Curie Chemistry by Qnisys. For the case of circuit functions take the 3 bottom steps of the Qiskit pattern and package it into a workflow. So optimize, execute, and post-process. There's no mapping step. So what this means is that the inputs are not domain specific. The inputs for circuit functions are abstract circuits and observables, and the outputs are mitigated expectation values. We think of circuit functions as being base functions that allow users to build applications on top of them. And today, we have 4 circuit functions available. We have IBM's circuit function. We have Tensor Network Error Mitigation, or TEM, by Algorithmic. We have Performance Management by Q-Control, and we have QESM by Kedma. Our Qiskit functions catalog today has 7 functions available to our users, and you can scan the QR code if you'd like to learn more. And we have a lot more in the pipeline. We expect to have more functions available in the coming weeks and months to add to this list. Now, to recap, we've talked about the progress in the hardware. I've shown you results showing that Qiskit is the most preferred and also the most performant quantum SDK. And now, with functions, we hope to simplify the process of doing useful work on quantum computers to a broader range of users. So I would like to invite all of you, let's unlock quantum advantage together, and let's bring useful quantum computing to the world together. If you'd like to learn more about functions, Paco Martin will lead a session at the IBM booth today at 1:20, so please feel free to stop by or scan the QR code or find one of us at the IBM booth, and we'd be happy to chat more with you. Thank you for your time.